What a waste. That is the first impression of 99% of those who visit the burning ground, where all day and every day trucks are arriving loaded with material for destruction. What a waste of effort, they say. It is a waste, of course. In some instances an unavoidable waste, in others just rank bad drill, carelessness in production. Yet with the best production in the world, some waste is unavoidable. And such waste, whether it be powder, bullet, cartridge, debt, shell, or contaminated material, must be destroyed or cleansed by fire as laid down in the General Safety Directions or Superintendent's Safety Orders. When you think of the vast and varied production of the factory, even 1% of waste would keep a small disposal staff busy, but the present rate of wastage is giving full-time employment to 124 workers on waste collection alone. Collections ranging from contaminated material by motor transport to powder under oil by small hand trucks. A staff of 124 to merely collect waste. Add to that figure the burning ground staff of 84, working in 3 shifts, and we have a total of 208 on the purely negative task of waste disposal in one factory. To prepare explosives in readiness for burning is a full-time, experienced, and dangerous job. In the shortened daylight of winter, the outside staff must work at full pressure to clear the ground of explosive matter before the night falls, when burning is impossible. The consoling fact in this vast mass destruction is that the quality of ammunition supplied to the fighting services is higher than it has ever been, and that it is better by far for inspection to condemn errors before ammunition leaves any factory than for faulty rounds to jam the guns of our fighting men when they face the enemy. Come over to the filling shop and see the detonator as it passes through the varied stages to the varnishing and beyond. At any one of those stages an error may occur, an error which may not be discovered until it reaches the inspection bench. An error at this stage can mean but one thing, rejection, and rejection means destruction. Both open depths and caps are conveyed under oil from the group waste station to the burning ground in the same manner. Here is a truckload of caps, which, like the depths, arrive in transit trays, each tray containing furnace tins, and each tin containing caps. Tins are perforated, allowing the caps to lie in oil, so restricting friction during transit. When checked at the gate, they are at once taken to the furnace house magazine to await disposal. Before either caps or depths are allowed in the furnace house, the furnace man must be satisfied that his fire will hold till destruction is complete. He must check and, if needs be, refeed the fire. Incidentally, 4 tons of coal per week are needed to keep pace with the present rate of destruction at this factory alone. Having satisfied himself that all furnace doors are securely bolted, he brings from the magazine 1 tray of death. 1 furnace, 1 tray. That is the explosive limit. Each tray holds 48 perforated furnace tins, and each tin holds 10 LACE detonators, or 15 fulminate of mercury detonators. Tins must be lifted clear of the oil bath and allowed to drain for 5 minutes. With the oil thoroughly drained from the tins, the furnace man, using a felt pad, picks up 1 tin of depths which he at once covers, the pad serving a dual purpose of soaking up the surplus oil and also giving slight protection should the man unfortunately slip. He must replace the lid before leaving. By means of a hopper, the debts are emptied into the furnace, care being taken to slide the tin into position, for it must be firmly held when the hopper is raised. A guard is provided for the protection of the worker, and from there he controls the hopper. The hopper is raised and the debts fall. 10 debts are in the furnace, 10 explosions should be heard. Explosions from 10 depths. Yes, but often 2 occur at one time. Satisfied all the debts have exploded, he leaves the safety of the guard. The hopper is lowered and the tin reclaimed. So the performance is repeated until the last empty tin joins those inverted on the tray. Every inverted tin must be an empty tin, and the return of a tray still containing debts is an impossibility. In the same furnace house, both filled and capped cartridge cases are destroyed, the only difference being the explosive limit. Capped 303 cases, such as these, have an explosive limit of 200 per hopper, but in actual practice that amount is rarely approached before the contents of the hopper are tipped into the furnace. Unlike the det operation, a safety guard is unnecessary. The filler tips and fills from the same position. He continues to fill up to some 2,500 cases, though he could with safety continue up to 7,500, the furnace limit. The explosive limit per furnace for filled cases is 5,000, and the hopper limit is 50. But remember, these are limits, and generally speaking, these figures are rarely approached. Meantime, the man prepares to rake the furnace, and safety rules demand that 1. He must wear the approved mask. 2. He may not open the doors until a period of 5 minutes has elapsed since the last filling. 3. He and he only is allowed within 10 feet of the furnace while it is unprotected by the guard. The guard must be filled to remove the baffle door, but safety demands its replacement at the earliest possible moment. The furnace is now raked to ensure that every case will receive the heat of the fire. Usually the explosion starts some 15 seconds after the first filling, but again safety makes a demand, and raking over the furnace is an added precaution. Once again the worker is exposed to possible blasts from the furnace, for the guard must be lifted before replacing the baffle door. So again the rule applies, only one man within 10 feet of the open furnace. While he replaces the door, notice the heavy armored casing so necessary to withstand the continual explosions within. The replaceable inner lining is useless after 8 to 10 weeks, and no wonder. With the baffle door closed and the safety guard lowered, the worker is free to remove his helmet. The heat in the furnace house is terrific. It says much for the fitness of the men that they bear so well the added confinement within the enclosed mask. But 10 minutes later, the helmeted figure is once more unbolting the door. The 10 minutes pause, which is enforced after the raking, has passed. So with every reasonable precaution taken, the work of removing the now harmless cases proceeds. 20mm capped cases provide another problem of errors. Sometimes the fault occurs in the very early stages, where the cap meets the case. Sometimes the fault lies with the ringing. But few pass the eagle-eyed inspection staff. That is a reject, to be reclaimed or destroyed. The depth of cap may be wrong, and so the snowball grows with every operation. 20mm cases are no longer dealt with in this form. In these days, the heads of the capped cases are cut off, and they alone enter the furnace. The explosive limits are 25 per hopper and 7,500 to each furnace. Otherwise, the drill is exactly the same as for 303 capped cases. The raking over, the helmeted worker, the 10-minute pause after raking, and finally, the baffle door unbolted and removed. Then, taking the usual precautions, the case heads in which the caps have been fired are removed from the furnace. But at least some metal has been saved, for the cutting off of the capped head has allowed over 80% of the case to go back, to be recovered for resmelting and redrawing, whereas had they been burned, none could have been reused for cases. A certain percentage of production waste occurs long before the explosive meets the cartridge case. Cordite, for instance, arrives in the shop in long strands, and for all types, such as Bofors ammunition, needs cutting to correct length. Whether it be this type cordite, or the thinner strands used in the 303 round, cutting will make waste as a saw makes sawdust. But unlike sawdust, it is useless, it is dangerous, and it must be destroyed like all other rejected cordite. before any open burning, the firing key and electric detonator must be drawn from the control hut. The firing key must remain in the possession of the overlooker during the entire preparation, not only for cordite burning, but for all burnings. Strands of cordite thrown out from the coil to give the correct charge weight, or found faulty on proof, arrive in boxes, and a trail is laid directly from the boxes. In laying a trail, due thought must be given to the direction of the wind. A brick, for later use, marks the start of the fire. A trail of faulty or contaminated neonite is laid to carry the flash from the fuse to the cordite. The overlooker prepares the charge by connecting up the electric det or fuse to a line running back to the control hut. He then positions the fuse in the neonite under the brick to prevent it jumping out when fired. The firing key must be carried during all these operations, and after all clear, handed over to the foreman. A 6-volt circuit is used to fire the fuse. He plugs in and makes certain everybody is clear, switches on the lamp, puts the key in the switch, and turns. The 20mm shell provides another example of unavoidable waste. After HE filling and pressing, the shell is cleaned first with a hard wood or copper rod, and after with a cloth. The unwanted HE is tapped into oil, which in due course will find its way to the burning ground. The detonator filling machine must be kept free from surplus fulminated mercury. During the shift and at shift end, the filler is thoroughly cleaned down and all surplus powder removed for disposal. This is how the disposal of fulminated mercury is carried out, as directed by GSD or Superintendent's Safety Orders. First, the preparation, the ingredients being the powder already in the oil, waste oil, and shavings. Quantities for mixing: half a gallon of oil to 5 pounds of powder and oil. Method: thoroughly clean the sludge from the cloth. Then pour on the sludge the oil from which it was taken. Meanwhile, the second man prepares the shavings in the mixed bin. These shavings have been previously examined to ensure that they are free from grit, metal, or other foreign matter. Then, after swilling round the previously used pail, empty the contents onto the sludge and mix to as near liquid as possible. During all this operation, the overlooker has kept a watchful eye for possible debts and caps which might have found their way into the waste bucket. It has been known. When thoroughly mixed, shavings are added and are stirred into the powder and oil. Mixing continues until the oil is dried up. The whole is then emptied into the mixing bin containing further shavings and again mixed, this time with a long wooden stirrer. So, unreclaimable fulminated mercury is prepared for burning. The waste explosive is brought by truck to the burning plate, onto which it is emptied and spread to form a layer. Safety orders demand that the layer be no more than 1.5 inches thick. To comply with this direction, the explosive mixture is leveled to the permitted thickness. The neonite trail is laid, into which is set the fuse held down by the brick, and, after the usual safety precautions to see that all is clear, the charge is fired. Plates and trays are seldom fired singly, usually in 3s or 4s. This is due to the large amount to be burned, and also, until the fires are burnt out, that entire part of the ground is forbidden to workers. So wherever possible, firings are in series. Meanwhile, other plates and trays are cooling in readiness for further firings. So much for powder from the filling of detonators. Now look at some of the dets in the advanced stage of the 20mm fuse assembly, where, having passed all tests, they have reached the point where, in company with the booster, they meet the gain, and so to form the fuse. It will not be the fault of this operator if these dets ever reach the burning ground, for she is careful in every detail. But before 20mm shells are finally completed, they must pass through other hands, through other operations. Shells may even reach the proofing stage, and yet fail to pass for various reasons, in which case the once perfect det would form part of a reject and so be destroyed. Such dets are transported to the ground in steel containers, each container holding 45 pots, and each pot holding 450 fulminated mercury dets, or 300 should they be LACE dets. These are at once taken to the magazine. It should be noted that only closed dets arrive in pots. Open dets arrive under oil and are destroyed in the furnace, as you have seen. The pots are prepared for destruction in pairs. One pot is placed on adhesive tape and then primed with the electric detonator. The second pot is placed on top of the first and secured to it by means of the adhesive tape. The pots are then placed in a double-doored hatch. Meanwhile, in a blasting pit heavily reinforced by sleepers and steel girders, a hole is dug in damp sawdust, and a wooden, not metal, spade is used for this purpose. From the outside door of the hatch, the pots are collected. These are carefully placed in the bottom of the pit and then covered with the sawdust. The trailing leads from the primed pots are now connected to the wires from the central hut. The whole surface of the pit is then covered with a tarpaulin, not for added safety, but merely to retain the sawdust in the pit during firing. From the control hut, the electric det is fired. To illustrate the value of the tarpaulin in retaining the sawdust, watch the effect of an uncovered pit. A familiar sight in any ROF is the safety escort and the men with det carrying boxes. This has bred a familiarity which borders on contempt. It is a bad thing, for the danger flag is a true indicator. There is danger here. Those red carrying boxes contain pots of lead azide, and azide is of such a treacherous nature that safety regulations demand destruction the moment it arrives. The carrying box is taken to the magazine, opened, and from it the 2 pots of azide are carefully transferred to the bench for future attention. The box is returned to the waiting carrier, and that man knows his job. Out through the guarded gate, he steers a course well away from the advancing second man. We show you this, that you might impress upon others the necessity for keeping well clear when they meet the det carriers, both on the factory roads and on the cleanways. Preparation for destruction is the same as for detonators. They are primed, taped in pairs, and put into the hatch. Using the outside door, the overlooker collects them and with great care transfers them to the prepared sawdust pit. They are buried, wires connected, and once more, for your benefit, fired without the tarpaulin. And that is the end of waste lead azide. Over on the 303 section, another operation nears completion, the rumbling of the 303 G Mark II tracer. Using white spirit, the finished rounds are thoroughly cleaned in readiness for weighing and final packing. It would seem a wide gap between this shop and the burning ground, yet it is possible fatally to bridge that gap by carelessness. Supposing a round slipped from the cloth to the floor and lay neglected. Rounds do slip to the floor. Supposing at break or shift end the cloth is picked up and rightly put into the waste disposal bin, what then? That cloth in due course would reach the salvage depot, the group waste section where all things for disposal are brought for examination, oil and powder, clothes and rags, clothes to be laundered, rags to be laundered or destroyed. Clothes for the laundry have hems where things secrete themselves. Some unreclaimable rags have hems, holes and slits where odds and ends find a temporary home. Into such our cartridge found a resting place. Tucked away in that hem, it passed unseen into the waste rag bin. The examined waste rag bin, where in company with other waste, it awaited removal to the burning ground. Every day this van arrives, and never a day does it leave empty. Not only contaminated rags, but also powder under oil is packed and transported for destruction. This is but one landing stage. On every group, everywhere, the same thing is happening. By motor transport, and where the groups are near the burning ground, by hand trucks. Everywhere the urge is to be rid of that which is not only useless, but if allowed to accumulate, dangerous. So the van arrived, to first deliver the oil and powder to the mixers, and then the contaminated waste directly to the burning hearth. This type of waste is usually delivered during the morning, thus giving the fires time to burn out before nightfall. For if fires do not burn out, they must be put out. The bins are emptied, and again the rags are sorted and examined as they are thrown on the hearth. But somewhere among those rags, the cartridge lay cunningly hidden. When all is ready, the waste heap is electrically fired in the same manner as waste powder. 2 hours must elapse before the men are again permitted near the hearth. It is then raked over to allow the fire to reach those parts which have so far escaped the flames. Buried beneath was something untouched by fire, and then you may think that little story a trifle exaggerated, but it does occur. Accidents such as that have only been avoided by the last-minute discovery of a hidden round. Where then is the remedy? The remedy is, if a round slips from the cloth, put it back at once. If a round drops to the ground, don't leave it there, that's the fault, but pick it up at once, that's the remedy. Be careful lest things you drop down hide things you should have picked up. Don't trust that your errors will be corrected by others. That applies not only to 303 workers, it applies to everybody. Yours is an important and dangerous job. Don't make the job of others more dangerous still. While on the 303 section, see the filling of the G Mark II tracer bullet, particularly at the amount of tracer powder which is wasted during the operation. From this near corner, the mold starts on its round journey. It is filled and pressed and returns to the far end of the same bench. Every so often the bench is cleaned down. Look at the surplus powder on this one bench. It seems a frightful waste, doesn't it? All that powder to be destroyed. And this operation, reamering or cutting back the powder after pressing it, is a very necessary operation and common to most types of powder pressing. As pressed powder is both useless and dangerous round the inner sides of a bullet, it must be removed. It drops onto the bench. It drops onto the floor, which is bad drill. The bench is there to sit at and work over. A reamering grid is provided through which to sweep the powder and at the same time to prevent the bullets following through. Because of the vast amount of powder on the floor, A broom and a pan is a very necessary part of the shop's equipment, but they are provided to sweep up powder and not bullets which have fallen on the floor. Bullets should be picked up. All surplus powder must be emptied into the oil in the waste powder buckets. There's a place for everything in this shop. There's a special drawer for dirty rags and another for clean rags. There's a special place for powder in oil. That's at the waste disposal station, where it arrives from its shop-to-shop collection. First, the thin top oil is poured through a fine sieve into a special bin. This oil, being sufficiently free from powder, will later be reissued to the shops to serve its same purpose again. Now follows a rough examination of the rags and the powder in oil. All rags, bits of string, in fact anything in the nature of cloth material, is separated from the sludge, sludge being the shop name for powder mixed with oil. When all surface material is separated, a wooden stirrer is used, and the examination and sorting continues until the sludge is completely free from rags. That sludge is now poured into a sieve which is padlocked to the bin. There's a very good reason for that padlock. It ensures that the sieve is used, that everything in the bin has been through the sieve. So, with the help of a wooden pestle, the sludge is forced through the sieve, allowing only the sludge to pass, yet retaining any foreign body, such as the bullet which we saw swept up in the filling shop. Bullets should never reach here. If a bullet is on the floor, then it should be picked up and put away, not swept up with the waste powder. There is but one good reason for the sieve, and for the care and trouble in this department in checking everything before it leaves the group waste station. Before the sieve can be removed, before the contents of the tin be emptied, the key must be handed to the waste disposal man. He is responsible that nothing but sludge is in the bin, and personally ladles out the contents into a container which will, in due course, be conveyed to the burning ground. Each container is lettered with the group and shop number. Each container is filled, closed, and cleaned, and then, as an added precaution, the container is placed in a large box under lock and key to await removal. After delivery to the burning ground and subsequent preparation by the mixer, tracer powder is brought to the trays. There's a difference between the burning of tracer or incendiary and the burning of fulminated mercury, and that is sawdust is used with tracer burnings and shavings for fulminated mercury. Sawdust, waste machine oil, and tracer powder are the mixed ingredients of this bucket, to which the overlooker gives a last-minute stir-up to ensure that the oil is well impregnated into the composition. This composition is now emptied onto a thick layer of sawdust, the overlooker making certain that it is all emptied by scraping out with his stick. Once clear of the bucket, it is separated as far as possible and spread over the sawdust. This is important. The tray is large and the sawdust is there in plenty, so the waste powder must be well mixed and spread before the near-night trail is laid. You may wonder at the amount of near-night used for these trails, but it is, of course, contaminated near-night such as would be swept from the bench of any near-night filling machine. It must be destroyed, so it is destroyed usefully. To pick up the flash from the fuse, which is held down by the brick. With 3 trays prepared and all precautions taken, the nearest tray is fired first because the wind is now blowing towards us. 3 trays of tracer in process of destruction. Again, the thought occurs, couldn't such waste be avoided? Watch this operation and judge for yourself. From here, the mold is passed to the filler, who positions the mold. Then from the box takes a scoopful of tracer, which she pours through the funnel, stems, and passes on. It is true that some are born clumsy, those who are all fingers and thumbs. Clumsy people never make fillers, and certainly they do waste powder. They and the operator who slams the overfilled mold crashing forward for pressing, but for the most part, there is little avoidable waste among tracer fillers, whether they be working on 303 bullets or 20 mil shell. Watch how this operator fills the measure with powder. She fills it to overflowing, and then with the handle of the scoop levels off. She tips the powder through the funnel. To the eye, not one grain of powder is wasted. Yet when she sweeps her bench down, surplus powder will be there. Even in the best production shops, some waste is unavoidable, and that waste must be destroyed. So many are the operations, so many are the inspections, that the shell of the 20 millimeter may be rejected at any stage of the filling. The rejection may be caused by pressing. It may be caused when burning. It may be reclaimed or destroyed. This is the method used when burning 20 millimeter tracer shells. Into the bin is tipped the shavings, a good generous layer of shavings, and onto this the shells for burning, 6 or 7 box loads. When all shells are in the tray, both shells and shavings are soaked with waste oil, old rags being used for this purpose. As with all burnings, waste near night is added to pick up the flash from the fuse, together with the inevitable brick. But there is just one thing which is different when preparing this burning. A large metal cowling is positioned to surmount the tray. When the fires are well and truly started, these shells would fly in all directions, hence the cowling. The trays are fired. But it will be some moments before the shells ignite. Nearby are shells which have passed through the fire. They are quite harmless now, for after the burning, when the cowling is lifted, every shell must be examined. Any showing the slightest trace of powder must be put back for reburning. Over on the depth section, see some good practice. Depths for external varnishing are tipped through the felt catcher into the varnishing sieve by a movement controlled from outside the cuticle. The felt is then removed by tweezers. Again, by outside control, the varnish is raised to cover the depth, paused, and then lowered. The depths must be allowed to drain for a minute before the operator, from the other side of the cuticle, gives the sieve a shaking to assist the drainage of varnish, and then draws the sieve over the drying pad onto which the depths are emptied. They are now a wet, jumbled mass, so a wooden spatula is used thinly to spread the depths for drying. That is not the full operation of the external varnishing, but it serves our purpose. We call your attention to the tray under the varnisher. This catches any drips which may fall as the varnish is lifted to the depth. You've seen correct drill, now see a glaring mistake. If that tipping handle is violently twisted, what is there to prevent a depth from jumping out and falling on the tray? The operator can't see the tray from the safety window. With successive varnishings, the drip tray gradually fills, and by the time it is due for a clean, that depth may be covered by the varnish. It may be wiped up by the rag. It is quite right to clean the tray, but it is quite wrong to clean before making certain that nothing but varnish is there. That cloth will be a hardened mass by the time it reaches the burning hearth. The fire was started, and tragedy followed. The carelessly thrown, tightly stuffed cloth was overlooked. That cloth held a detonator in its varnished grip. A jet dropped by carelessness, picked up by a cloth, thrown for open burning among other wastes. Where then is the fault? How can a detonator be prevented from reaching a burning ground? The answers are many, but if the initial fault be corrected, there is no problem. That is no way to tip depth. Time and care should be exercised. The same care in tipping as would be taken if those blast walls did not exist. Some thought given to those who, by lack of thought, might be maimed for life. We digress from our theme, which is not human, but explosive destruction. We commenced this film with a thought, what a waste. We are now not so sure that it is waste. We've traveled the shops and seen operation after operation. We've seen much good work and just a little bad. We've seen shells rejected, thrown out, as you would a rotten fruit. We've seen the most careful of operators sweep her machine to find surplus powder, as the cleanest of housewives will find dust in the home. But, and here is the answer, is the product good? Yes. Does anything but superlative work go into the ammunition for our fighting men? No. Then by all means destroy that which is bad and cannot be reclaimed, and good riddance.